For number 10, our first step is going to be to take the logarithm of both sides. So this is going to be log of 10 raised to the 1 minus x, and I'll put that in parentheses, is equal to log of 6 raised to the x. And again, the reason why we take the logarithm of both sides is because it allows us to bring down those exponents to the main level. So I have 1 minus x times log of 10 is equal to x times log of 6. Now this one's kind of interesting because we have log of 10, and log of 10, anytime the number on the inside of the logarithm matches the base of the logarithm, it's actually just equal to 1. So essentially, it kind of just crosses itself out, because 1 times 1 minus x is just going to be 1 minus x. So essentially, it's just going away here. And this is equal to x times log of 6. Now, I do have multiple x terms on this one, so I do need to get the x terms to one side. So I'm going to choose to move this one over there. So I have 1 is equal to x times log of 6, and to avoid confusion about where the logarithm or the inside of the logarithm starts and ends, I'm going to put the parentheses around the 6 and then plus x. So this is really to signify that 6 is on the inside of the logarithm and that plus x is on the outside of the logarithm. And then, just like with the previous problem, having the x's all on one side, I can factor this. So x times log of 6 plus 1, this is all equal to 1. And then if you divide both sides by log of 6 plus 1, then x is equal to 1 over log of 6 plus 1. And that'll be your answer in exact form. And then if you find the decimal approximation, it'll be 0.562382. And that'll be your answer.